Question 7. If you see something like this, you should suspect that this is generally speaking a Pythagoras theorem type of question. Pythagoras applied in a three-dimensional plane. The diagram shows the cuboid. Point X is a point on EF such that EX to XF is 3 to 5. So EX is 3, XF is 5. That's what they are telling you. And because you have the length AB, you can obviously directly find what is EX and what is XF straight away. Calculate the area of the trapezium ABXE. Where is ABXE? ABXE is this trapezium over here. So don't go and draw the wrong trapezium, please. This is the trapezium that they are looking at. Right? So I need to find the 3 units there, right? So I need, obviously, EX. And why in the world is it 3 marks? EX is equal to 3 out of 8 times 24, which will give me 9. So I know that this is 9, and therefore this will be 24 minus 9 to give me 16. Right? Not 16, 15. If I know EX is 9, half times sum of parallel sides, which is 9 plus 24 times perpendicular height, which is, told you already, Cambridge like to give you all 3 marks one. Like that is 3 marks. Like that is 3 marks. So I guess 1 mark goes to finding what is EX, which is kind of ridiculous. If you, in the exam setting, randomly forget how to find area of trapezium, then you just go and divide the trapezium into triangles and rectangles, and then go and find them separately and add them together. Calculate xg for 2 marks. Where is xg? xg is this length over here. Take note that xg is on the same plane, right? So we already know that xf is 15. And then we know that BC is equal to FG, which is 13. So which triangle am I looking at? I am looking at a triangle that looks like this. Right? This is a triangle, XGF. A lot of you don't have a habit of drawing out the 2-dimensional triangles that you are looking at in the diagram. Okay, bye. Draw it out. So we know that this is 15. We found it just now. We know that this is 13 given in the question. And therefore, by Pythagoras theorem, xg is equal to square root of 15 square plus 13 square, which is equal to, I will leave the 5SF value in case I need it later on. If you are comfortable leaving it in certs, you can technically leave it in certs, but not a requirement. Normally, we just leave it in 5SF first. And therefore, it's 19.8. Okay? Free 5 marks so far. Now we come to the hard part of the question. For 5 marks, calculate the area of BGX. You should look at this and realize that there is no way that you can find this by half times base times height, right? So in other words, to find this area, what are you likely to have to use? Is your other area formula, right? half AB sine C. So in order for you to use half AB sine C, I found XG. So always annotate what you have found. I know what is this. Right? Do I know XB? I also know, no, I don't know XB. I never found XB yet. But can find or not? Yes. I can find, right? I should be able to find XB easily, right? Or if you don't want to find XB, what else can you find? You can also find BG, right? In fact, you can find all three lengths, isn't it? Quite easily too. We know that this is 8. If I draw a line down, we already established that this line over here is 15 and this is 8. So when you look at all the other triangles that I can visualize to find BG and to find XB, you realize you can find all three lengths. And if you can find all three lengths, what can you always use? You can always use cosine rule. What? You can always use cosine rule to find one of the angles. Okay? So you can always use cosine rule and therefore find one of the angles. You cannot use sine rule here because you don't have any of the angles. So the only way to do it is to go and find all three lengths. So we are going to go ahead and find all three lengths. So by Pythagoras theorem, Bx is equal to 15 square plus 8 square, square root of the whole thing, which will give me 17. So it's even a nice exact number. What else? I want to find BG. BG is square root of 13 square plus 8 square. Again, by Pythagoras theorem, right? (15.264) in 5 SF. So I know that this is 15.264. Is there a next part of the question that isn't? Which means I need to just find any single angle. It doesn't matter which angle I find because I just need one angle and the two lengths to go and use cosine, to go and use half AB sine C, right? So by cosine rule, I am going to find the cosine of which angle? I'm just going to find the cosine of angle BXG, but it doesn't have to be BXG. It can be any of the three angles, to be honest. Cosine BXG is equal to A square plus B square minus C square over 2 A B. So you must know how to apply your cosine rule to go and find the cosine of your angle. You want to simplify this, you can simplify this. You don't want to simplify this, also up to you. In fact, you'll find that the answer is almost like an exact value, right? Because actually, if you think about it, I don't need to go and find the square of, I don't need to find the value itself, right? Because in cosine rule, I'm always using the square of the value if you actually think about it. But anyway, it doesn't matter. So you will get this is equal to 0.66679 in 5 SF, and therefore angle BXG is equal to cosine inverse 0.66679, which will give you 48.180 degrees, again in 5SF first, and therefore area of triangle BGX is equal to half. Make sure you know which angle you found. I found BXG here, so this is 48.180. So my half AB sine C is half 19.84 9 times 17 sine 48.18 degrees. And this will give me 126 in 3SF. So is it very difficult? No. Pythagoras to find the length, cosine rule to find one angle, and then half AB sine C. That's why the question is 5 marks. The application of cosine rule to find the angle, generally speaking, is 3 marks. So the half AB sine C, I guess, is 1 method mark and then 1 answer mark. So using Pythagoras to find the length, I think does not give you any mark. But it's a very straightforward thing anyway. All right. So make sure you know how to work your 3-dimensional figures.